Yesterday, I showed the factor analysis graphs, right? Showing how these, and I'll get you those slides. And so we showed how the trajectories of these different indices are passing through, in the case of that one older woman who tested with us, the retired OBGYN here in Scottsdale. Her indices and her overall score were passing through 5 main factors. And so there were 5 underlying equations that were determining her predicted score at her 3rd retest. So that would be December 6th, right? And so we're going to go, we didn't do that for this report. This is just an anonymized report that we've had. I picked a random one, and we're just going to go through and see what is being shown. So first of all, here's the cover page of every report with a unique barcode. These long barcodes are now going to be replaced by a shorter barcode with our customized kits. So we just got those in, and those are now going out. So this very nice box, very professional and put together. We always show the collection date, the analysis date. This is just to confirm that the times are within 10 weeks. That is how long the analyte retention is validated for off the dry blood spot card. We always, of course, give the analytical platform, where it was tested, etc. This report is long, and of course, it needs a table of contents. Our original report, which some of you may have received, didn't have this, so it was just a flurry of information. So it goes through. First, we have a summary page, and then we have detailed results of those 12 key health domains. These are the proprietary domains that we have validated that underlie things like mitochondrial dysfunction, and specifically things that are not just mitochondrial dysfunction, but sources of them, whether it's mitochondrial DNA damage, lipid peroxidation, liver health. We're looking at things like, is it too much alcohol consumption? Is it potentially something connected to an environmental toxin that's being detected? Maybe some inherent mutations that are limiting cytochrome P450 or conjugation pathways related to the liver. So every domain really contains a subset of anywhere from 4 to a dozen things it can pick up. And it's sort of truncated into this construct of a domain. And as we saw yesterday with the slides, there really is usually anywhere from 2 to 5 factors underlying a person's health score, right? Now, in very complicated conditions and cases, those may be more than 5 factors that really act as these nexus points for determining trajectories. And then we have our digital twinning protocol, disease signatures, and then we have an appendix. So we always want to give the raw values that come off the mass spec, as well as a range to interpret that univariate wise. And then our methods and references for everything. So first of all, we see this individual is overall normative. So he's a metabotype 2. He's normative for most of his domains here, except he's optimizing his gut health, and he's scoring poor in mutational load. We scroll down a little bit more, and we see the general aims that we're going through, right? So sometimes, just by looking at this, without pulling up or creating the Gantt chart that we saw yesterday, with the Gantt chart or the linear equations we saw yesterday, we can take a look and see generally what's going on, right? We know that he needs some taurine supplementation here, so there's probably something going on with taurine, hypotaurine, xanthine, hypoxanthine metabolism. We do see some issues here with antioxidants and glutathione popping up. And then we do see some fatty acid metabolism that is pinging. And so these are the top things this person is supposed to address. It's just a summary page. It does not show, again, any sort of equations, nor does it need to. It doesn't show any sort of dosages, timelines. It's just a quick capture of that person's next steps. So when we look at this individual's aging index, we see that their sarcosine levels, and we're in the process of replacing these bar plots. So these are just enrichment plots, and they basically show at sort of biological maximum how full are they, right? So in enrichment, it doesn't matter if somebody's 100% enriched or 110 or 20% enriched, which is mathematically possible, they're still going to have 100% here. We're replacing these to have essentially a range. So the range that corresponds to that metabolite, right? Because we always want to give a little bit more information. The first version of this report didn't even have that. It just had an explanation of what's being detected and a score. So it was something that physicians had asked for. I just want to kind of get a rough gauge of where this person's at. So we put these enrichment plots in. And then in our next iteration, we'll have a range of values. And you can see where they lie relative to that univariate interpretation. But keep in mind that the univariate interpretation is not going to serve you well. We talked about this in the context of succinic acid yesterday with mitochondrial health. This physician was insistent upon 2 really poorly conducted studies. However, she thought it was really quality work because it was in PubMed. And as I explained yesterday, I could write a letter to my mom this afternoon, and by tonight it's going to be scraped and published on PubMed. PubMed will put anything up there if it's even tangentially related. So we'll have a range which will give you a rough idea of fold change, right? And fold change is what's important. We saw those volcano plots. We saw a few studies where we went through the biomarker discovery phase, where we qualify these biomarkers not just on high or low. That can't be done. How high? How low? How significant? What's the beta coefficient? What's the variable importance and projection? How does it contribute to model accuracy? Is the model overfit? These are things that we need to think about, not just, oh, they're high in this one biomarker, I think it's cancer, right? So this erroneous interpretation is a little bit aggravating for me, but we're trying to go and do some more education and reach out and hopefully show people the depth of this work and that it's not some weekend thing you can sit down with or a physician who's not really that well trained in biochemistry to sit down and interpret this and understand the backdrop of diagnostic work. Biomarker discovery and validation is its own field. So we have these box plots, or these enrichment bars. We can see here that they're doing relatively well. Their spermidine is through the roof. We want to keep that up. Their sarcosine is a little bit low, so methylation processes are a little bit compromised. I believe they were already taking niacinamide. It's not as high as it should be given their dosage, I think, and we'll go into that when we get to the digital twinning section. Their stearic acid is looking okay. It could be a little bit lower even, and their cadaverine is okay, but given the diet that they reported, we did have some concerns. For their nutritional index, their ferulic acid is great, right? Glucose 6-phosphate is a little bit low, so there's probably something going on with carbohydrate metabolism and probably need some more complex carbohydrates. Oleic and linoleic acid can be a little bit higher. These nucleotides are a little bit low. It's telling me that they're not getting a good protein intake. And so taurine, again, taurine is good. I think this individual, if I remember correctly, they were taking some taurine, but it needed to be at least maintained. Glutathione's okay, should be a little bit higher. Guanosine's incredibly low, so they do have some need for guanosine, which is going to have a very potent anti-inflammatory effect. Their GABA is a little bit low. Mitochondrial health, we see issues in citric acid. We see issues in adenosine. So this is telling us that the start of their TCA cycle and the end of their electron transport chain is aberrant. There's something going on there. We see issues a little bit in succinic acid. Malic acid is okay. Oxoglutaric acid is this linchpin factor it's a really linchpin intermediate in the TCA cycle. It is the plug-in for 2 out of the 3 anaplerectic amino acids that plug into the TCA cycle. So this should be maybe a little bit higher. Cardiovascular score, again, adenosine's really, really low. It's really impacting it's really impacting their mitochondrial health, but we know that it has vasodilatory and cardioprotective effects as well. So it's affecting their cardiovascular health as well. Palmitic acid is kind of medium, it could be better. Homocysteine is in the sort of normative range there. Linoleic and alpha-linolenic acid could be a little bit higher. Again, they're taking niacinamide supplementation, but it's not as high as we would expect it to be. Inosine is low in this individual, right? We see inosine is very, very low. Taurine is okay. Serotonin is in a good range, but for their age, I believe, this is a younger gentleman. This should be a little bit higher. Liver health, again, amino acids are okay. Urea cycle metabolites are a little bit high. We do see ornithine and citrulline. We want ornithine and citrulline. These are good things for the liver. And when we see high metabolism, these urea cycle metabolites, it usually means low ornithine and citrulline. So we want to bolster that. We see some fatty acids. These are general. When we say fatty acids, it's usually these three here: palmitic, oleic, and linolenic. Their gut health, their tryptophan metabolites are low. Amino acids are good, right? So start to visualize this as we go along, right? We are seeing the recurring issues in this person's metabolomic profile. And their gut health is good, right? It's like optimized. But their tryptophan could be a little bit better, right? Their amino acids are great. So they're having good gut health, good gut motility, good signaling. GABA's a little bit low. Again, serotonin could be boosted. Adenine and adenosine, they're taking taurine, but it's not as high again. Glutamic acid is okay. The glutamic acid is okay, even though the diaminopamilic acid is low. So this is something that is actually going to modulate glutamate receptors in the brain. So it's a little bit low, but the glutamic acid levels are high. Myo-inositol is good. But there's really honestly very little evidence to show that you can have like way too much myo-inositol. It gets throttled in absorption, and we really do want inosine and inositol in this individual. We're seeing that in their profile. Integumentary health, again, taurine could be a little bit higher. We kind of do want a little bit more linoleic and linolenic acid. Their membrane health is really great. That's a good level of ethanolamine. Adenine and adenosine, again, these are kind of be really important for cellular repair and energy, of course, and these are a little bit low. Environmental toxin exposures, taurine could be higher, glutathione could be higher. Their adenine, adenosine, inosine, and guanosine is very, very low. So it's coming up again, adenosine, inosine, inositol, these are low. Malic acid, fumaric acid, succinic acid, citric acid, it's kind of in the middle. And that, if you remember, is because this citric acid is so low, right? Citric acid, citrulline, these were low metabolites. Mutational load, again, this person is suffering from a severe lack of purine metabolites. This person is going to have a diminished flux through these DNA and RNA synthesis repair pathways. And again, taurine and glutathione, which we want more of, it's kind of in like the 65% range there. So now we get to their digital twinning protocol. So we see that they're high in spermidine. They were really high in spermidine. We're not recommending a supplement, but we want to ensure that they continue the intake that's giving them this high score. It's a linchpin in their digital twinning protocol. We're asking them to aim for 1 milligram a day. For niacinamide, again, we saw it was high, but it wasn't as high as it could be. So we're postulating there's probably some issue with absorption. So we want them to continue with the 500 milligrams daily, but split it into 2 doses. And let's see if this helps with absorption. The next thing is stearic acid and cadaverine, right? Stearic acid was a little bit low. The stearic acid was low, and their cadaverine was kind of middling, right? If I remember correctly. This is I got kind of lucky because usually reports aren't this one-to-one match. Sometimes we'll have high succinic acid and we'll recommend more succinic acid for some reason that we have to go really into the pathways and figure out. But in this case, we see the stearic acid is low. Cadaverine, we want it as low as possible. Okay, cadaverine is not a molecule that is actually used for anything. It is a bacterial degradation of lysine. So we want this as low as possible. And what's our recommendation? I think I picked a good one, even though it's at random. We want them to continue, we want to consume some stearic acid, right? We're asking them to go in for the dark chocolate, the cocoa butter, all the good things. We're also wanting them to limit their red meat consumption to 3 servings per week. This is to curb these cadaverine levels, right? As a high source of lysine, we want to reduce the bacterial digestion of lysine to the production of cadaverine. We don't know what cadaverine does, right? This metabolite is in the panel because I discovered it. And it's a really good piece of research, and we included it. And it's validated as statistically with permutation testing in our model. We don't know what it does. We know how stearic acid works. We know how spermidine works. We know how niacinamide works. There's no mechanism for cadaverine, but we know that it doesn't contribute to central metabolism. And we know that it's associated with death, right? So it's named after cadavers, right? Putrescine, cadaverine, these are these sort of like polyamine substances that are associated with death. They increase linearly as we age. So we can use it actually as a very sensitive indicator of if somebody is, what do we do in our study? It's 21 to 40 years old and 65 years old. So it's a very rough gauge of age, but it can bin people very easily into one of these three ranges, okay? 20 to 40, 40 to 65, or 65 plus. So that's where the digital twinning comes in. The oleic acid was a little bit low. We're asking them to be intentional about putting 2 tablespoons, very slight nudges, right? Ferulic acid, we want them to include some more ferulic acid. This is a great antioxidant, and it's going to actually be, for us, it serves as a marker of diet diversity. Glucose 6-phosphate, remember, was a little bit low. So we want to make sure that they're getting complex carbs from vegetables, whole grains, and legumes, right? This is a metabolite of complex carbohydrate metabolism. As glucose is phosphorylated in the cell, it becomes trapped, and it becomes committed to the metabolism of that cell. Their nutrition, did I skip one? No. Oh, we did nutrition. Inflammatory score, right. So their taurine was a little bit, it was like middling. It wasn't low, it wasn't high. But they reported that they're already taking taurine, right? So we're asking them to continue it. It's going to contribute to their inflammatory processes. But remember, the taurine and glutathione were connected in one of the domains. They're weighted together as an average in one of the scores. Forgot what score that was. Oh, there it is. Mutational lows. They're lowest scoring things. So taurine and glutathione, individually, glutathione's a little bit lower than taurine, and their average is not so great. So we're asking them to add NAC, which is the glutathione precursor, to enhance detoxification and reduce inflammation. And then spermidine and spermine. Just make sure you're getting these through the soy products and the legumes. We did not recommend supplementation for this individual because they were at a good level already. Mitochondrial health, right? Their succinic acid was low. So was their citric acid. And their alpha Kg could have been higher, right? Because we want this metabolite to be high. So we're asking them to consume foods, fermented foods, just 1 serving a day. We're also asking them to continue their CoQ10 supplementation. I think this individual was taking 100 milligrams. We upped it to 200 milligrams, 1 dose a day. And we're asking them to start supplementing with alpha Kg, right, 2-methyloxyvaleric acid at 300 milligrams a day. It's a pretty high dose. So this is meant to give fuel to the oxidative phosphorylation, the metabolic fire of the TCA cycle, by identifying, either in this domain or, as we'll see in other domains, aspects of the TCA cycle that were low.
May I interject?
Sure.
Here? This is where you as the physician are going to come in, and you're going to go, because I didn't know what alpha-ketoglutarate was. You're going to have to go and figure that out, because your patients are going to look at that and go, what the hell is that?
Yeah. So alpha-ketoglutarate is also, by itself, it's great to have high. But if it's high with low amounts of subsequent metabolites in the TCA cycle, so if they have low succinic acid, low fumaric acid, low malic acid, it starts to actually become a marker of glutamine addiction, which is one of the hallmarks of cancers, right? So the process of glutaminolysis, whereas glutamine becomes digested and plugged in as alpha-ketoglutarate, that is something that can be detected downstream as well. And this is not thankfully, what this individual had. Cardiovascular health, oleic and linoleic acid, again, comes up. So this is like the equations we saw yesterday. This is one factor that is going to address multiple domains. It's still listed explicitly, but it is that node in the factor analysis model that is predicting what's going to move the needle the most on this individual. Taurine, we want them to continue their taurine supplementation. It's looking good. Continue the niacinamide supplementation. Remember, we're splitting up their dose. Taurine, again, coming up. Taurine is the most, actually, we were talking about taurine, but I didn't mention this yesterday. It's the most important metabolite in our panel. It really is, as far as its appearances in the domains, its calculation of scores, and its weight in those domains, right? It's usually somewhere between the middle most important domain that's weighted in that, metabolite that's weighted in that domain, to the most important. So we want them to continue the taurine. Inosine, remember their inosine levels were like 0 almost, right? So now we're starting them with inosine supplementation. This is, again, a younger male. We want them to make sure that they have good sperm motility. And serotonin. Their serotonin was a little bit low for their age group as well. So again, ensure some adequate tryptophan intake, because we're going to create serotonin from that, the precursor. 1 or 2 servings a day. Very small changes. We're not asking them to come, I'm sure you have patients where you tell them, like, you are going to be on a ketogenic diet now. You are going to do some hardcore intermittent fasting. We're asking for very slight nudges in the right direction. Now, when you keep in mind the predictive structure of that data underlying these suggestions, you should never underestimate the synergistic effect of consistent cumulative changes. And that's kind of what this health approach entails, is targeting those factors underlying the scores, making these slight adjustments, and then overall we should see these improvements.
And how long do you typically recommend, let's say, what we're discussing here, the supplementation for? 3 months, 6 months?
Right. So it depends on each health domain. 3 months. Or that's how long we want them to do that for.
And then retest.
And then retest. So it depends. It's based upon how dire their score is. We want to retest more often if the score is pretty bad. But it's also based upon the intervention, right? For instance, I've done so many, Alex hates these, but I've done so many studies on vinegar, like acetic acid. You know how it was like really popular like back in the day, right? Like take some vinegar and do some stuff, right? I think I just submitted another one with her too and came back major revisions. I'm sorry, Alex. And so we are looking at vinegar for many things. We're looking at vinegar for depression, visceral adiposity loss from DEXA scans, metabolomics. We've put in, waist circumference, there's like 3 studies that we've done on this thing. And so then the latest one was like depression and visceral adiposity. And so if our goal is to reduce visceral adiposity from this vinegar trial, right? Let's say we don't recommend vinegar; it's not in our database. But let's say it's vinegar, right? We would say, well, in our study or the studies that we've mined this data from, randomized controlled trials. It was a clinical trial we conducted here at ASU on the 2nd floor. We did a 8-week follow-up. This other group did a 6-week follow-up, and this other group did a 9-week follow-up. Okay, we'll average that, given the effects we want to see, and we'll say, well, to give ourselves adequate power, which is a statistical concept of what's your chance of type 2 error, not like significances, but what's your chance that you're going to detect an effect if it's there, essentially. We want 80%. So we look at these studies and we see at what point did they reach 80% power, and we recommend that to you as a minimum to say, do not retest before this, because there is a chance, there's more than a 20% chance that there is going to be a chronic effect that we're not going to be able to detect yet. So it's based upon 2 things. The one factor is how dire is their score. The second factor is how long does the literature say it took to observe an effect? And there usually is in some sort of, it doesn't have to be experimental, like a randomized controlled trial. It can be an observational trial. It can be a case cohort trial. But they usually do have a baseline and a follow-up. And so that period of time is something that we kind of average and incorporate into our recommendations.
And I'm so sorry, I know you're on your spiel, but so many questions.
Yeah.
So how sensitive is this testing to what you do? In other words, if I drink coffee that I usually would not because I flew when the 2 of us met. I drank coffee, I never drink anything that has caffeine, and I did the Theriome testing. What I'm trying to formulate as a question is, how sensitive is this to the lifestyle changes, nutrition, exercise, supplements, and whatnot?
Incredibly.
Yes?
Incredibly. And so that's why we have rules for when you should sample, right? 8-hour water fast, ideally within 1 hour of waking up. There are some rules for this. And these are guidance and guidelines set forward by the MSACL, so the Mass Spectrometry Association for Clinical Labs. So labs that use mass spec, because mass spec is so sensitive, right? It is inherently prone to false positives. It's inherently prone to potentially false negatives. If you have this deficiency in amino acid metabolism and you eat a steak and then 15 minutes later you take your test, those amino acids are going to cover up our ability to detect this problem in amino acid metabolism that might be there when you're in a fasted state.
So in other words, we would want to test a patient or a client who that represents the most common conditions.
Absolutely. So we always advise people, if you have had an acute sickness, wait until that passes and then test with us.
Got it.
Right?
Okay.
And I believe that was an issue with maybe your test, right? Was it you?
No,
who had like a cold or something, and they were like, oh, I don't know if I should take it.
Yeah, it was not me, but it was one of my clients. So it's really good to know that.
Yes, absolutely. Yeah, Justin.
So layman question, but just I know for me, like being an active person, which is a lot of clientele for this, I exercise, so I always have high bunt levels, high liver enzyme, things like that. Would we want to make sure that a client abstains from any intense exercise?
No. Keep what you're doing the same. No changes in diet and exercise for at least 2 weeks prior to taking this test. Yeah. And so we put this on the website. It's in the book. It's now on the card, right? Take it in the fasted state, 1 hour, right? It's on the new test kit. So we do talk about this guidance, but maybe we should be a little more explicit about it. Yes, yeah. The main thing is the fasted state. That's the main consideration. So there are mandatory and recommended guidelines by the MSACL, and of course the fasted state and maintaining, no sickness, no acute illness, chronic illness, of course, like we want to figure out what's going on, but acute illness and no changes in diet and exercise or environment. So as we talked yesterday, there are changes in geography. We can use metabolomics to tell somebody, okay, you're from the East Coast or the West Coast. Biomarkers of geography. Alex will tell you about how different continents and countries have vastly different microbiomes. So if you're traveling from here to, let's say, Morocco, and your microbiome shifts, and then you take the test there, that's not going to be really indicative of your metabolism at home, because as we know, 50% of the metabolites in your body will undergo some sort of interaction and change with the microbiome. So if you change the microbiome, if you change that internal bioreactor, the metabolic interface within the blood is going to be different. It's not going to be a reliable snapshot, right? Yeah. But as we talked about yesterday, what's the coefficient of variation, as they say for clinical studies, like how much they should change interday and intraday, should be like 20%, right? Our values changed like 4.89% last time we checked. And we also do a quality control sample between all of the batches. So let's say we're running 20 samples in a batch. We'll run a quality control sample. We'll run 10 samples, another quality control sample, 10 samples, another quality control sample to end the run. And then we look at the coefficient of variation between that. And so it's one sample. It's a pooled sample of everyone's blood in that batch. It doesn't go anywhere. Nobody reads it. Nobody analyzes it. But that is used as a marker of how much performance drift and accuracy that mass spec is drifting throughout the run. Things can change throughout the run. So we want to make sure that the metabolites that we're detecting, first of all, have a signal-to-noise ratio of 3. The second consideration is how much are they changing? We don't want these things to change more than like 4-point-something%, right? I mean, really 5% is our like internal limit. And we do tunes regularly. So we bake the column after each run. Before each run, we tune the instrument. We make sure everything is right. And then we run the samples with the QC. So we have some internal ability to identify that and control for any variations that are going to throw off the statistics and interpretation. Yeah, that's going to be inherent, though, in the sensitivity of mass spec, right? Like if we were going to use NMR, we would be able to get lots more quantitative data, and it would be far more reproducible. We talked about this yesterday with why are we using mass spec? Why do most researchers in the field of metabolomics use mass spec? It's because it's 10 to the 6 times more sensitive. That's why we're able to look at 2 microliters of your prepared sample and in a mode that's known as splitless mode, and make sure that entire helium packet is delivered to the detector and is able to read it, right? This is the technology they use in airports when they dust my shoes for bomb residue. They're looking for residue that's been cleaned up. It's at an inherently low concentration, so they use a handheld GCMS that's only going to detect some volatile compounds. And because they're volatile, they don't need to be derivatized. They just sample it, spray it, and the guy doesn't know what he's doing, but I know what he's doing. So, okay, so yeah, this was the cardiovascular health, the reproductive health. We talked about this, sperm motility, didn't we? Yep, inosine, yep, yeah. Okay. Liver health, again, we're asking them to add that N-acetylcysteine. Palmitic acid, we want them to reduce saturated fats, so limit the consumption of high-fat meats. And so this is an instance where, we were talking about high-fat meats the other day. How do we tell the difference? In a case where palmitic acid might be too high, it doesn't matter if it's coming from steak or hot dogs. Limit that, right? I'm a big fan of ribeyes, but if I only eat the fat off the ribeye, it doesn't matter if it's coming from the ribeye, if it's a center cut, primal cut, right? It's high fat. Urea cycle metabolites. Remember this issue we had with the urea cycle metabolites, where it was really high, right? And we really know that when urea cycle metabolites are high, that the liver isn't processing well. It's inversely associated with citrulline and ornithine. So we want them to add these foods, meat, lean meats, as we were saying, limit the consumption of red meats because of the palmitic acid and also because of the lysine that's contributing to their cadaverine levels. And then aim for 1 serving of these foods 6 days a week. So just make sure you're having 1 serving of meat and a watermelon slice. Yeah.
Sorry, I have many questions.
No, that's what you're here for.
So with the liver health, is there an indication there related to, let's say, like fatty liver disease?
Mm-hmm.
And where is it?
So it is mostly going to be when we see, if you've seen a recommendation from the digital twin that says, in addition, check your ALT, AST, bilirubin, and what's the other one we give? Albumin. And these 4 are because we're detecting some sort of hepatic steatosis, right? We can't tell between NAFLD and the alcoholic cirrhosis. We cannot tell. So the signature is roughly the same. But if you see the recommendation for liver function tests, and sometimes, I've seen a few recommendations where we say fatty liver disease suspected, get a liver sonogram, right? Go get a FibroScan or something. Yeah.
And do we test for C15, the essential fatty acids?
No.
They're coming. No?
Yes, maybe. Yes, maybe. Okay. So we were talking about this the other day, right? Like it's a C15. We really want to look at the gut with that, right? Because we don't make carbon 15 fatty acids. This is a gut bacteria. This is a gut metabolite, right? We don't have odd chain fatty acids that we produce. These are gut derived. So we want to look at that, obviously. We can do lipidomics. We can get you 400 lipids, like incredible detection, incredible resolution, down to, how many carbons, how many double bonds, where are those double bonds?
Wait, you can?
We can. Yeah, we just haven't commercialized the assay, but we can do this.
Oh my gosh, you guys.
We can do short chain fatty acids, which is so with our gut test is going to have a stool test for sequencing the bacteria, and then a little bead mill tube that Micah put his feces in and sent back to us. So we're going to do short chain fatty acids. So we're going to look at the composition, but also the signaling potential of the gut bacteria. Okay. We've published the protocol for short chain fatty acids. It's in current protocols in Wiley, but we haven't commercialized it yet. We have the component to do it. Like I said, we were just talking with Gail and Robert last night, and this is a conversation I believe you and I have had. We can do deep molecular profiling right now. Whole genome sequencing, large-scale transcriptomics of 2,000 plus RNAs, 900 proteins, couple that with a very deep 6 million read sequence of the gut microbiome, and then our metabolomics. Maybe even an Aristotle Plus that we've developed that's 339 metabolites, but there's no report accompanying it yet, right? No pipeline for that yet. But we can do it. So if you have somebody who wants to spend $25,000, $30,000 a year and get a true N of 1 study done on them with 1 round of whole genome sequencing and then periodic monitoring of their other levels, and then every time they would produce this research style report on them, we can do that. We can give you the healthcare of dictators.
Are you giving Mike a heart attack right now?
No, he's on board. If it's for 25, 30K, he's like, okay, fine, like just do it then. But we can do this. We can bring this incredible detail right now. But we're focusing on what can we put in a kit. What can we make the kit look nice? I wish I had one of the kits in the office. Can you grab it? So we have this new kit. Like we want to make it a nice kit. We want the microbiome test to come in a nice kit, and we want the report to be nice, right? It's kind of like user report. If somebody wants like a Nature paper written about them, come to us. We will do that for you. We will write an N of 1 Bayesian analysis on you, going from your nuclear DNA to the transcription of RNA, the translation to proteins, interactions with the microbiome, and overall metabolic expression. We can do that. It's not going to look it's not going to be in a pretty kit, and it's not going to come in a report. It's going to come in a research-style analysis where there's going to be, stacked bar plots. There's going to be beta coefficients. There's going to be all the stuff we saw yesterday from the studies that are behind this, right? So gut health, they were doing okay. They were actually optimized. They were doing something called a stress support probiotic. Don't know. But the AI can look this up online, see kind of what's in it, and postulate what effects it's having on this person's gut, right? So, Aristotle, there's the kit. And so, yeah, so this is what's going out now. And so we want them to continue this. It's having some effect, but we're adding some prebiotic fibers that specifically contain inulin, right? We want them to have this protein. And this is going to come from foods like chicory root and Jerusalem artichokes, 2 or 3 servings a week. Tryptophan. This came up earlier for the serotonin issue that we wanted to boost their serotonin. Well, tryptophan on its own is a powerful signaling molecule, especially in the context of the gut-brain axis. Neurocognitive index. Continue their GABA. They were doing GABA at 500 milligrams. I think they reported something like 300, and we bumped it to 500 because their GABA was a little bit low. Again, the tryptophan comes up because the serotonin is really important in a few things, right? Serotonin is important for reproductive health. It's also important for neurocognitive health for obvious reasons. If you remember, their inositol was really low. Their myoinositol was really low. So we're asking them to add an inositol supplement at a relatively high dose of 2 grams a day for cognitive function. And they also reported some issue with mood fluctuations. So it picked this up, and it's saying, hey, do this for your mood stability as well. We saw yesterday the individual who we were going into that very deep case study for. She had ADHD, PTSD, bipolar, and one of the things that we recommended, of course, was these meditations and Tai Chi exercises for different domains, but also cognitive behavioral therapy, which is proven to be incredibly effective in a clinical setting for neurocognitive health. Integumentary health. So this is coming up with the nutrition index as well as skin health because it's really important for skin health and barrier integrity. Fatty acids, nuts and seeds. Vegetable oils are okay with limited use. Aim for 1 or 2 servings of nuts or seeds a day. Yesterday we talked about seed cycling, and this was recommended for an individual coping with the symptoms of postmenopause, right? So premenopause, perimenopause.
No, she was probably having PMS.
Okay, all right. So seed cycling for these issues is really important, especially as we modulate fatty acid profiles and affect hormone metabolism. Thus, so we have hyaluronic acid. Skin hydration and elasticity goes hand in hand with the fatty acids. And then again, taurine. Keep taking your taurine. You're taking it, keep it going. Glutathione, we already said, start a dosage of 600 milligrams twice a day. Taurine, keep going. Antioxidants, we want you now, see, vitamin C and E. Great antioxidants. We want them to add citrus fruits and nuts into their diet. 1 or 2 servings a day and support citric acid. This is a mitochondrial correction that is stemming from some sort of factor that's mostly affecting her environmental toxicity. So it's not, so we put them in these like silos, like environmental toxicity and mitochondrial health. What you saw yesterday in that graph was there is no silo. There's 4 or 5 underlying factors that are really bringing down these scores, right? So we saw in there, where's the mitochondria? I think it was low. I hope it was low, or else I'm totally wrong. There's citric acid. Was it low? Yeah, it's depleted. They have no citric acid, but we're not recommending this in the mitochondrial domain, right? It's recommended in the environmental toxicity domain. My guess is, if I were to open this up and take a look at what's under the hood, whatever's affecting the environmental toxicity is what's causing this mitochondrial depletion of citric acid, the first part. So it's really weird that the first part of their TCA cycle and the first part of their electron transport chain is off. So as you can see, these are great to look at individually, and it's kind of like a fun, oh, that's interesting when you look at the univariate single metabolite level. But when we start looking at the pathway level, we see these patterns. And that is what AI is really good at, is pattern recognition. That's its main thing, right? And then I think we just have the mutational load. This was really low, right? Okay, just go in for a variety of fruits and vegetables, vitamins A, C, and E. They had reported that their diet was mostly carnivorous. We see that impacting their mutational load. But we also see that the protein that they're consuming is not really being put to use. And so they're saying, oh, I eat a lot of, most of what I eat is meat. And then when we looked at the servings that they were having and the caloric intake, it was very, very low. So most of what they're eating is meat, but they're still not eating enough meat. And the adenosine and guanosine levels were really, really low. So we're asking them specifically, have 2 to 3 servings of this a day. And then taurine and glutathione, again, we said continue with the taurine and begin this NAC supplementation. This NAC is really going to, as we talked a little bit yesterday, is these DNA repair mechanisms that happen mostly at night when we're sleeping. These are incredibly sensitive to oxidative stress. When you have a high oxidative burden, these enzymes that identify SNPs and mutations and correct them in the sequence, these are going to be compromised. So we are recommending this NAC for a few different things. It appeared in multiple domains to boost their glutathione.
Can I ask you, why
Yeah.
not just recommend like something like perfect aminos, just amino acid supplementation, as opposed to saying like, tell me.
Meat, right?
Yeah.
Or why do we recommend spermidine through the diet and not through, right? So a lot of times when you have a synthetic form of something, right? Let's say, you're taking magnesium phosphate, okay. To get the magnesium rendered in a bioavailable form, what do you have to do? You have to dephosphorylate it, right?
Oh.
Let's say in our metabolites and the patterns that we're detecting downstream, we detect some issue in a gene, in a SNP, related to this dephosphorylase enzyme, or we detect some issue in the enrichment analysis of the 912 enzymes we monitor that is related to this. So we're saying that we aren't sure, because we're not looking at the gene itself or the enzyme, but there is a statistically significant chance that you're impaired in your ability to dephosphorylate this supplement and make it bioavailable. So take it from, apples to get your magnesium.
Got it. Thank you.
So the disease signatures, here we have, again, a list of what they pinged. Total, we only report the top 20. We profile 480. There's a ton in there that's significant, but we just don't report it. This freaks everyone out.
Yes.
But the weird thing is, we had individuals who tested with us, had high colorectal cancer things, and then next week we're like, I got diagnosed. Totally independent of us.
What percentage would be the significant percent to go check?
So here's the thing. We profile 480 disease states. We report the top 20. You can tell roughly disease burden by just looking at what proportion of that 480 are they statistically significant for. Some people will be significant for a couple dozen. Some people will be significant for 120 of them. Some of them will be significant for 200 plus. We're only going to report the top 20. If we tested, we have almost tested everyone in this room, all of us are going to have 20 significant disease signatures. All of us. What's important is how many of them matched. And what's even more important than that is how they changed longitudinally through time. We had an individual who came and they had breast cancer, right? And they're in remission. They're really worried about it. They pinged positive for that breast cancer signature. Is it back, doctor? Well, probably not, unless you're having symptoms or something's changed. Probably not. We're not detecting any other things. But let's keep an eye on this as you retest. If this goes up or down, it might be a good time to go see your physician and have a discussion about this section of the report. And providers, we don't give this information out, but if providers want, they'll say, which of these 54 did they match with? And again, it's not that they matched. If I were to analyze everyone in this room, we're all going to express the 54 metabolites that are underlying this disease signature. It is like those volcano plots. How much has it changed and in what direction? What we know is that of those 54, 16 of them changed in a manner consistent with the reported signature of breast cancer, or in this case, colorectal cancer, right?
So is there a cutoff? I'm going to go back to your question. Is there a cutoff as far as the percentage? Everybody that we
No.
so far is about 30%.
Yeah, no cutoff. Sometimes it'll be 80, and you'll be like, ooh. Sometimes it'll be 100 for something that's like histidinemia.
Right.
Sometimes it'll be for like inborn errors of metabolism, like, lactoniuric protein intolerance. If I had to bet, that's why we're not giving them, right. And then the lysine is also what's being metabolized to cadaverine. So these results play into one another. We are addressing many aspects of the disease signatures. We just can't tell you that because we're not treating anything here, okay? We are running your data, and the data is informing what your trajectory could be, and that discrepancy informs how we're going to improve you over time and engineer that.
And so when we test, is there a way to get the difference between test 1, 2, 3, 4, and 5?
It's coming. It's coming. No, very soon. We are actually building a portal, and that portal will have like an area for like historic data. So you can track disease signatures. You can track, hopefully, well, I know you'll be able to track the domains. Hopefully we can work in the disease signatures and be able to show this historical trend over time. Yeah.
Can you go back to tests that didn't have your, for example, my test done long before you gave the first part of this report?
Sure. Yeah. I can bring it up. Yeah. And then so after the disease signatures, here we have the relative abundance. Again, we give this information. We want you to each one of these is like a character in a play. I always like biochemistry because it was like a story. Like I've always viewed this as a story whose characters are these compounds and these genes and these kinases and whose actions are determined by math. This is math. I was a math major initially. I know that this is all just a complex series of intercorrelated equations, right? This is, yeah.
It's
No,
not a story.
it is. No, it is. It is. This is Game of Thrones. You missed the paper we presented yesterday.
Oh, no.
It is. It is a complex set, and Alex knows this, and the people who we work with know this. This is essentially structural equation modeling, like on steroids. This is all just a series of pathways, path diagrams, and statistical correlations that are informing each other. So that's what we're trying to uncover here. So you have all this information, and it goes on and on. It used to be like one metabolite per page, and we've kind of truncated. So it's not 150 something pages anymore. It's a manageable 76. It's so funny because there is this, that meme of who is it? It's like Leonardo DiCaprio in that movie Django Unchained. You remember where he's like kind of like laughing? He's like ha 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 ha, right? There is that meme, if I can't find it here, and he's kind of like laughing, and it's like, the genome, 20,000 genes, and then it's like the proteome. 60,000, it's a transcriptome, 60,000 transcripts, 200,000 proteins, and then it's like the metabolome, and it shows, Leonardo DiCaprio kind of like laughing, and it's so many. We have indexed 25,000 metabolites, and we know that there's in excess of 2 million of them. We're giving you 126. What that should tell you, and it's 68% of known metabolism, what it should tell you is that we know nothing about metabolism yet. We're getting there. All right, bear with us. I wish I could find that meme. Okay, so this goes, wow, it really goes on. We should do something about this. It's all the explanations. It's like, hey, here's uridine diphosphate and acetylglucosamine. Cool. Or UDP glycanac.
It's really helpful because you also reference it.
Yes, go pop this into your, and then so for the for the actual domain pages, we have actual citations. These are actual citations, and they're in the back. But for this, we thought, just put the DOIs in there.
Are you looking at this appendix very much?
It's a good question.
I did on mine, and I actually had some questions because the same number came up, 57 came up on over probably 25% of the metabolites. It was like, that's weird.
That's because it's mapped to an internal standard, like we said. We use 3 different internal standards because there's 3 broad chemical classes, chemical structures. And so it's mapping to a different internal standard, but the count's the same.
Okay.
If we were to report this in a micromolar concentration, they would be different. Yeah. We don't do that, though. Even though we have the internal standard, really what you need to do is do a concentration gradient for each one of these metabolites. If we did that, this would be a $5,000 test. So we use an internal standard that is very reliable. They're always 90 to 99% R squared. So they have a 90 to 99% agreement with the actual concentration. But that because it's mapped to an internal standard, it's technically considered semi-quantitative. And in the literature and in metabolomic sciences, you're not supposed to report that. It's kind of unethical or dishonest. So you report relative abundance. So relative to the internal standard, that was the count. So one of them is 57 relative to a certain internal standard. That internal standard is different probably between the molecules. And so the counts, technically the concentrations are different even if the counts are the same.
Are you considering having 2 types of the reports? Because the overwhelming reaction that I got from almost all of the clients is like, this is overwhelming. Because they get it in an email before they typically come and speak to us.
Yeah. So I don't know. We get some people say, I want the physician's report give me something that the customers aren't getting. Give me more complex details. Give me like the real statistics. Like put graphs in there, right? And then we also get the people who are like, I don't want this. I don't care. Just give me like the protocols.
Yeah.
Give me the scores and protocols.
You don't need to read it if you don't want to.
Yeah. So that's our philosophy currently is we are coming out with a physician report that's going to kind of break down even like it's not going to have scores. It's going to have the 70 organs we monitor, the 912 enzymes we look at, the disease signatures will still be there, the SNPs will be there, and it's all going to be in enrichment form. So you're going to see graphs, you're going to see like figures like we had in the studies. We're hesitant to do that because we're already getting a lot of comments and questions from you guys about this. What happens when we give you the real meat and potatoes? I'm going to be on the phone all day with you guys talking about this, that. So everybody wants it until they're served that, and then they're like, actually, where's the light version?
Exactly.
And this is the light version.
About the light version. But then whenever I'm looking through it, I was thinking that maybe for a patient it has to be just 1 page or 2 pages, like morning, this supplements, or like breakfast, this foods, lunch, this supplements, this foods.
That's a great idea. It's something we've considered. We do see that when we do that, the question is, yeah, but how do you know it's this supplement? So now it's like, okay, take inosine 2 grams. Why? Well, because on page 3, look at your inosine levels, right? So it can't be almost truncated to 1 page because there's this incredulous approach that customers have. Is like, oh, these guys are telling me what to do, but I want to know why.
Right, but they will see the explanation later. But these 2 pages will be specific for like foods to eat, and they can see later on the pages why, or supplements to take, and then they can see why.
Yeah.
So some of them they cannot, especially like people who are like cancer patients who were just diagnosed. They are like a chicken without the head, running around, don't understand anything, and they just like, give me something simple, what I can do right now.
But that's
But
what I'm
that's
saying.
your job.
Yeah, that's what I'm saying. That's really where your value comes in, is
Yeah.
you're doing that for them. You're
You are
taking this
translating.
data and you putting it to them in a protocol
Some
somehow.
size protocol like you did,
Yeah.
right, exactly.
Exactly. So we have our digital twinning, but Gail creates an ultimate protocol, right? And then that's 1 or 2 pages, like slides, square, 4:3 aspect ratio. Go have at it.
I think this gives you an awesome opportunity for, I hate to go back to sales, but like you can say, hey, we have all this stuff. We're going to focus on these 2 for the next month, and then we're going to get to these. Now you can future pace the client treatment program and say, hey, we're going to be with you for a year, but this is where we're going to start.
And when we do the consults, right, Greg, we are focusing on the lowest scoring domains. We're focusing on those nexus points in the factor analysis model that are going to move the needle the most. So when you come to us for the consult, we're going to we're happy to answer questions about any aspect of the test and any of the recommendations we gave for any domains. But in the consult for this gentleman, we would most likely focus exclusively on the mutational load and really hit the recommendations hard, show the pathways, why are we doing that, give enhanced guidance on timing or dosage if applicable, and that's kind of, we focus on the lowest scoring thing really during the consults, but we're happy to answer any questions that the patient or the provider may have. Yeah. Are you sure? Okay, so methodology, again, this is, we're scientists, right? Like we always have to report our methods. So this is how your sample was prepared. These are the steps that we went through yesterday, like the 22,000 spinning Gs. Basically just taken from a protocol and finding 70 microliters of supernatant are taken. It's really two microliters, but it's 1 microliter kind of injected in succession. This is the protocol. This is the you can recreate this. Like if somebody wanted to, they could buy this mass spec, buy the column, hire someone like me to run it, but then you could buy the standards that we have, confirm the spectra. We're not going to give you our retention times and our massive charges. You have to figure that out. But if you buy the standards for these compounds, you could recreate this test. And then this is the methodology. Like we saw yesterday, right? We have the normalized intensity, and this is their retention time, and this is their mass to charge. So this is what a 3D spectra looks like. This is what the machine sees. And the intensity correlates to, this is the normalized intensity, normalized to the relative standard. So even if they're the exact same, like these 2 peaks, their values are technically different. Yeah. Their concentrations are, their values are the same. Metabolites, quality control, and then references. So we always want to show where these domains, the scores that we're calculating, what studies are they trained on? Mostly, right? And so that is the presentation. I'm going to disconnect while I...
Computer.
Huh?
I don't have an HDMI.
Right, I'm just going to show Gail's report real quick. I just don't want to go in and broadcast a bunch of patient names. Robert's going to file a HIPAA complaint if I do.
I have no doubt. I was just trying.
He's the HIPAA officer.
Well, it's all fun and dandy when they show up.
Right.
Yeah, right? Then they show up and it's like, oh, 1 point, how much? 1.7?
You know, it's funny that they increased the fine from 1.5 million to 1.75. They said because there is inflation, they had to do this. So everybody was like, "This is funny, you guys."
Inflation and fines?
Yes,
They're ridiculous.
that's exactly my point.
Oh, so Gail, you give me permission to share this?
Yes.
Okay. You all heard it.
So,
Robert.
some things are good, some things are awful. I'm just going to preface it.
And this is our old report. This is not what we put out anymore. And very soon you'll have like a portal to view these scores in and order more tests and look at historical data. We have a team of really smart guys, IT tech guys that are working pretty quickly at it. So we just started this how long ago?
6 weeks.
Yeah, like 6 weeks. Yeah.
Initiating the actual project.
Yeah, like what's the cost and how long and everything. And they've already got like the login, the credentials, admin roles, and some like dashboard items already done. So yeah, they're working at a fast clip. All right, I'm gonna press the down button. So this is what it looked like. Right? This is like our old logo. Everything has changed. Like the logo of the company, the report, everything has changed. And this is really honestly due to the guidance of Micah, because if it were left to us, we would just give you like statistics and have you go like figure it out. Micah's like, right, here's an Excel. We send those sometimes, man. Yeah. Not even Excel, like CSVs. Like that's, yeah, that's the real, that's how you feed it into code. You gotta give it CSV, you can't read Excel. So this is, these are Gail's results. Okay, and a few things, Gail. You look great. Mitochondria are pumping, your gut's working great. Everything else is kind of normal. And then cardiovascular, reproductive, liver, and integumentary just bombarded.
Yeah.
Yeah. Yeah. Actually, so they're weighted differently. Like this overall health score doesn't, it's like integumentary is not as important as liver or cardiovascular health. The number one domain I think is cardiovascular. Number two is liver, but not by much difference. The ones that are actually weighted less, not because they're not important, but because there's really not so much we can change with them, are things like mutational load, aging, or aesthetic domain like the integumentary health.
Can I ask you, how is it possible, I'm sorry, Gail, that you are 10 on aging and basically have cardiovascular, mutation load, all of this that I would consider would be relevant for aging?
Okay,
Low.
well, except the markers that they're looking at for aging, obviously my markers there were good. I mean,
And they're different. They're different markers, yeah.
And they are. And, I looked at this and I said, wow, I wanted 10s on everything. Again, everybody has test envy. But I learned more about the scores where I'm like dire in than I did from the other ones. And so I made those changes in those 4 areas that are in the red that I've now implemented into my personal routine.
And aging is rate of aging. Like we're not saying that, like your heart and liver are terrible, but you are like a 34-year-old or a 25-year-old or whatever. We're saying that your rate of aging is slow. And that can be the case even without these domains being high. They're based on totally different metabolites.
I get that.
Yeah, and when we do, like for instance, we were talking about the aging paper yesterday. So I did an aging paper. It's published in Neuroscience. A lot of great people on there. And we had to control the model for chronic disease. Because we have 3 groups of subjects. As they get older, we just see a chronic disease burden. And so if we were just to say young, old, find biomarkers, go. Or do a regression equation, find biomarkers on a continuous variable of age. Don't even dichotomize them into young and old. Just do a continuous analysis. You're going to, on the higher end, get lots of model bias because those people are usually suffering from chronic diseases. So we calculate what's known as a chronic condition score. We include that score as a quantitative score into a model that corrects that and makes sure that the signal we're getting from aging is related to aging and not to cardiovascular disease or endometrial cancer or fatty liver, right? And so this is just to show how awful it looked. But it's basically just like, hey, here's an explanation of it. No chemistry, bar to show like roughly how enriched or depleted am I in this profile. And this was it. This was the protocol. This was the pages. And same information. It's the same information. We're not changing how we report it. It's just what we were reporting. We're changing how we were reporting it, right? So it's just not a sort of plain text protocol. It's the same text. It's the same stuff. There's your colorectal cancer, everything going on, dengue fever, sepsis. Wow. That one doesn't pop up often. And then every page had this essentially, right? So this was the
That's where you're going to see 57 a lot.
Yeah. And actually, we have done a factor correction because we used to also report, like, if something wasn't detected with a sufficient signal-to-noise ratio, we would just make the whole range the same as the detected. People wanted to ask, does this mean that there's no range, or like, is the range the same thing as where I'm at? So what we did was we said, okay, the signal-to-noise ratio on this particular metabolite wasn't as high as we'd like it to be, as long as it's above 2. Even if it's not above 3, what we do is we now do a signal subtracted reporting. So we can report the range, analytically it's valid, and there's no question as to, hey, my score is the same, or why is the high and low range the same as the analyte? So we've corrected a lot of these things just to correct for confusion. We're scientists. We report things as we would report them in the literature as we're writing a paper. So as we see that, we're not testing scientists. We're testing normal people, right? And as they're not understanding things, we go, okay, how do we maintain the integrity of the results we're reporting? We can't report absolute concentrations. This is something that, if my PhD advisor knew what I was doing, he'd hamstring me. It's just a cultural thing. We don't do that. It's not technically based on a concentration grade. It's based on a relative abundance. But we can do things to make sure that's not 57. We can do things to make sure the range isn't the same, by doing some, signal-to-noise subtractions and some corrections to the internal standard. But as you can see, it's the same sort of report, and it goes all the way down.
I think mine was 150.
149, yep. And then we had the same sample preparation. We added some figures to show the 3D spectra and limitations of the test, which are always really important to know. And that was the end of it.